Okay, Assalamualaikum and very good morning. Couple weeks ago, I do touch about the quantitative representations of the flow behavior, how you're gonna find a good model, try to represent all three stages of the pseudoplastic behavior. So from now on, I try to pre-record my lectures and you can download it and watch it online. Alright, continue with our lectures. Okay, if you still remember the first model that I did touch about the power law index, where the power law index have the capability to accurately model the pseudoplastic regions. And now we're gonna take a look what is other model that can represent the lower Newtonian, which is the zero shear viscosity, and the upper Newtonian, which is the infinite shear viscosity model. So what is the advantages of the power law? If you still remember the advantages of the power law, we turn to this one. All right. The advantages of power law: it can accurately model the pseudoplastic region, but it neglect the Newtonian plateau at the small and large strain rate. But I want you to focus more on the power law model because it's very important. All right. So the next model, in order to overcome the disadvantages of power law models, we can use the Carreau model, where the Carreau model make use of viscosity function that have finite value both at the low and high shear. So if we take a look on the Carreau model, it have four different parameters, which is the viscosity, right? Viscosity and node is the zero shear viscosity, and n infinite is the limiting viscosity at high shear stress. So the most important parameter in Carreau model is the lambda c. So lambda c is a time constant. It's calculated from the reciprocals of the strain rate at which the zero shear strain rate component and the power law component of the flow curve intersect. Okay, this is the pseudoplastic behavior, and this is the upper Newtonian. So it cross over at this point intersect, and this is the lambda c, right? So if lambda c strain rate power of 2 is less than 1, that means the viscosity behavior represents the shear zero shear viscosity. If the lambda c strain rate power of 2 larger than 1, that means the viscosity behavior of the material represent the infinite shear viscosity by the Carreau model. In many cases, the equation that I show you, we can neglect the infinite shear rate viscosity. So if we neglect the infinite shear rate viscosity, we can arrange back the equations become this equation, all right? And this equation we can include a temperature dependence and express as this equation with additional parameter, which is the AT. Okay, and it have few different constants, K1, K2, and K3. Okay, how to get the AT value and how to calculate the K1, K2, and K3. Alright, in order to calculate the AT value, you have to define, okay, whether the polymer is amorphous thermoplastic or whether the polymer is crystalline, semi-crystalline thermoplastic. If the polymer is amorphous thermoplastic, you should use this equation. Okay, so last year this question came out in the final exam. So I don't give the formulation. You have to memorize the formulation for the amorphous thermoplastic and how to find value AT value for the semi-crystalline thermoplastic. E naught is the activation energy, and T naught is a reference temperature. R is the gas constant. Okay, this is the value of K1, K2, K3, K4, K5, T naught, and E naught. This one If this come out in the final exam, I will give the value for the K1, K2, K3, K4, K5, T0 and E0. What is other model other than Carreau model? So other model we can use cros model to rectify some weakness of the power law model. So we have the power law model, we have the Carreau model, and third one we have the cros model. Alright, the cros model it also take considerations on the zero shear viscosity and infinite shear viscosity. Alright, and but it used different equation. In the Carreau model, it doesn't use lambda c, but it used the n value. Where you get the n value? N value is the power law index value. So you combine between the power law index to produce another model, which is the cros model. Alright, so in many cases, again, the infinite shear rate viscosity is negligible. So the equation can be rearranged and become like this. So the most important component in this equation is tau star, which is the critical shear stress at the transition of the Newtonian plate tube. So if we take considerations of a constant K equal to n naught divided by tau star, for a good data fitting, the apparent stress can be shifted by setting by using this equation. Alright? And then again, if we neglect the zero shear viscosity, so it can be modeled using this equation. Again, you can use D1, D2, A1, A2 constant from the given table as follow. So if this model come out in the final, I will give the uh, value for the tau and D1, D2, A1 and A2. Right. The most important thing is you have to know what is the difference between the power law models, the Carreau models, and the cros model. For the power law model, as I told you, it can model the pseudoplastic region accurately. Alright. For the Carreau model, it can model either the zero shear viscosity regions or infinite region. Only one of them. Alright, but it can also model the pseudoplastic region accurately. Alright, and for the cros model or modified cros model, it can show represents both zero shear viscosity regions, infinite viscosity regions, as well as the pseudoplastic regions. But the disadvantages is the difference between the cros model and the power model, it have some error. I mean, the value is a bit lower compared to the value of cros model is a bit lower compared to the power law model. Okay. So now we look on the comparisons between models. Okay. First, as long as you don't approach the upper Newtonian regions or the lower Newtonian region, so there is no parallel basis on which model you should choose, because you should choose the power law model, right? Because the differ is only on the sharpness of the transition from the lower Newtonian to the power law regions. Next one. If your polymer is polydispersity index, all right, you should choose the cros model. And if your polymer is monodisperse material, so you should choose the Carreau model. All right. Another thing is, if the process you use is extrusion and injection molding, so you should use the power law model. However, in the process such as compression molding and hand laid up, you can use the Carreau model to suit it well. I think that's all for our lecture.